Is I don't know who wrote that song, but somebody's jamming out. Good evening. Welcome back. Session 2, the evening session. It's good to have you all back. So this morning we did exactly what we're going to do today, or tonight. It could be today where you are. I don't know. It could be morning, evening, afternoon. We're going to build out MCT. And if you weren't here this morning, I'm going to explain it. So if you were here this morning, I'm going to explain it again. So you get to put up with it twice. But what we're going to do is, I'd spoken over time that I wanted to start building out the entire RUCKUS portfolio so that we could really sit down and see us start to build our technology on top of things, right? And the first thing that we need to do is build a network infrastructure where we can host Smart Zone and Zone Directors and all of our infrastructure. So we need to build out our data center basically. And that's what we're going to do, but we're going to build it out and we're going to use MCT. And then as the weeks progress and we do the live streams, I'm going to start to build out, we'll have some access points attached to Zone Director, and then we'll start to migrate those off onto Smart Zone. We'll show you how to do that. We'll include things like virtual data plane. We'll include dynamic VLANs and DPSK and radius authentication. And we're going to go through the whole thing because I think that this is a great platform for it. It's a great way to kind of do the how-to stuff and show you the demonstrative pieces of it. And it's a lot of fun because we get to interact with you in this way and do this. And yeah, it's a good time. So couple things. If you were planning on attending last week, I had to cancel it last minute, had some unforeseen circumstances. I do apologize for that. I didn't want to do a half-baked product and put it out there. So I do apologize. We should be good to go now. But life happens. And as we all know, the world's weird and wild right now anyways. So yeah, so let me do this. I'm going to show you one thing first real quick, and I've got to unhide one thing. I'm going to make this bigger because I'm going to show you the environment we're going to be working on. There we go. This is the network environment that we're going to work on, okay? And for all intents and purposes, you can ignore, 95% of this. We're going to work on this piece down here, okay? And one of the things, I'm going to make this a little bit smaller because as I have to come in and use it later, I want to be able to reference it, but I don't want it to chew up the whole screen. One of the things to kind of note here is we're implementing MCT and we're going to implement it across all 3 of our access switches. Those will be MCT clients. I didn't include the second one this morning because when this lab environment is fully built, one of the servers is a DHCP server and it serves addresses for not only v4 addressing, but also v6 addressing. And MCT can forward IPv6 traffic all day long. It just can't route it. So we'll get to that when we get to it if we do IPv6 in labs. The wireless side, especially in management of devices, it's not necessary right now, so I don't foresee that, but if we do some deeper dive ICX stuff, we will absolutely do that and put it together. And we'll expand on the ICX stuff that we're doing as well. So as I always say, if you have suggestions, if there's things that you want to see on the live streams, ruckuslive@comscope.com, send us an email. We monitor that mailbox, check it all the time. Let us know. We'll put something together and we'll include that in the stream. I don't think that this is going to be built to where a certain cadence has to be followed, day in and day out. So I don't want to sit here and say we've got to put together this one platform and this week we're going to build the ICX and next week we're going to do the AP migration. We can do different things at different times because the beauty is this is all recorded. It ends up as a video on demand and we have it on our YouTube channel, which if you're not subscribed, I would recommend that you do. Tons of great content that's updated all the time. And, I use our content and I know the folks that put that content together and work on it work very hard on it to put a great product out and they do a good job of that. Second thing, Brian Stewart is here. He's going to hang out for a bit and I can't say enough about Brian, and anybody that's heard me speak knows that I can't say enough about Brian. So one of the smartest people I've ever had the pleasure of working with. He's also probably one of the smartest people that you've ever had the opportunity of learning from. And further, he's probably one of the friendliest, most helpful people on the planet. So he always keeps me straight, makes sure that the stream's going the right way. And then also there's some stuff coming later on where not later on, but later on in the year, next year, you'll be able to interact with Brian in a new way as well. So I know I'm super excited about that. Brian's super excited about it. And if you're not, you should be. So, okay. So here's our plan. Okay. My eyeballs are going to be all over the place when I do this because it's a pretty large environment. I have a lot of notes in a lot of different places, and I have the memory of a gnat. So you're going to have to bear with me. I'm going to build this out a little bit differently than I did this morning. I'm actually going to, well, I mean, everything's debatable when you really come down to it, Brian. We're going to build the ICL and the client lags first. So I wanted to go through, and I just kind of winged it this morning because I do this stuff in a lab, and I throw it together, and if it breaks, it doesn't matter to me, right? Because I don't have any live production traffic going through it. So I can break it, and that's fine, because if it's broken, nobody's going to call me and scream at me that there's an outage. Then we'll do the keep alive and the session VLANs, and then we'll go ahead and build a cluster. I'm more than happy to deviate from any of that if you have questions and there's things that you want to see on the ICX side. I'll help you out and show you. This is all being done in 8090 software within the ICX, so we're not doing anything crazy. It's just 8090 UFI software. And then I was going to say something else, and of course it's late and it's been a long day and I can't remember what it was, so that probably is to your benefit, I guess. So anyways, again, welcome. Thanks for joining. Happy to have you here. And yeah, it's going to be a good time. So one thing to note, if this is something that you're looking at doing, this is really meant to just be a demonstration, a kind of a how-to. This is how you do it. This is how it looks when it's done. These are some of the gotchas, that kind of thing. Always have a MOP method, a procedure put together, because the way I'm doing this doesn't guarantee that you won't interrupt traffic or have some kind of outage. So don't go piddling in this until you've actually tested it out, especially if you're trying to lay this into an existing production environment. I don't want you to get that phone call, because I've had them before and they're not fun at all. So one more thing I was going to show you. So just so we're clear, these are the devices that we'll be talking about. So we have, I need my mouse to behave, and I apologize, this diagram is on my tablet, but I did a driver upgrade for it and a software upgrade for it, and it erased all my buttons on my pen, so I can't get my annotation worked out. And anyways, it's just one of those things. So I'm going to be working on 5 devices. This is distro 1, distro 2, access 1, access 2, access 3, and like I said, these have the lag indications. This one will be lagged as well, and a client. So those are all the MCT clients. Their config is pretty clean, pretty simple, nothing crazy to it. So yeah, if I get into a spot and you have questions or you're wondering, yell at me, say, hey, wait, stop, hold on, go back, I want to see that. So I think the first thing that I said we're going to do is we're going to build the ICL first. Okay, and we're going to build the ICL between this device here, which is distro 1, and distro 2. And as I do this, I have a tendency to try to haul sometimes, so I'm not going to do that. As I do this, the ICL, we're going to create that as a static lag, and the static lag is required for the ICL. And the reason for that, which we talked about this morning, I'm just trying to find my note on that real quick. Give me a second. All of the control traffic for MCT is done there. RSTP states for the client lags, max sync, everything is done there between those two peers. So that's why, just based on system limitations and requirements, that's why that's there. So we're using a static lag, but it works great. So don't panic when you see that. Okay. So first thing, I'm in distro 1. Ignore the prompt or the host name. We use this for the lab stuff that we do. It's just for our resets and for dropping configs in, and it just keeps my brain sane. And plus, this lab is in California, so if you live out there, please don't hit the power switch. But this just helps us communicate with the lab team out there as well. Like, hey, I need you to go work on this device. This way we know what it is, where it is. So the important part's the middle. You see that it's distro 1, right? So config T, and we're just going to start out. We're going to do lag, and we'll call it ICL, and we're going to do static ID of 1. Okay, so that means that our lag interface will be lag 1. Okay, and then add the ports. So Ethernet, I should probably do this 1 by 1 by 1.7 to 1 by 1 by 1.8. Okay, deployed successfully. Now that's half of it, right? Another thing, and I'll do this as an example because I probably will forget or get in a hurry or get lazy, one of the two. And it's a lab, so don't judge me. But I really like this feature, just adding port names so that when I look through the config, I physically know what ports are going where. And I'm a stickler for this kind of thing, especially in production environments, even with non-production environments, an environment like this that we utilize so heavily. This is important to me because if I build this and then later on I'm having problems with it and I say, hey, Brian, can you come take a look at this? And everything's labeled and he knows what's supposed to be where, it just translates really clean. So even if you can do this in a production network, you absolutely should. I think it's a best practice and I think it should be practiced. And you probably already do, but you know, if you don't. And then if you're putting spaces in your port name, I don't know if this changed in 8090, but I add quotes around it just so it's clean and it knows. And then I'm going to name that port. And then all I'll do is just do the same thing for 18. Now I know what's what, right? Super simple. Okay. All right, so got that done. And keep in mind the way I reset this lab earlier, it's probably not going to be up. Nope, it'll be down because it's down on the other side. So when I tore this out earlier, it just disables all the ports when I'm establishing the lag. Now I'm kind of curious if the ports are disabled from that, and it disables it to avoid a loop. When I tore those out, I'm curious now if I put it back in, if it brings them back up automatically. So that's a good thing to note too, right? If you do this, then you know, ooh, if I create a lag on these ports and they're disabled, they're going to come up, right? But probably just on the side where they were already disabled. Making tech sense. Thanks for coming back, man. It's good to have you here. And hello back. Well, it's good to have you here for a moment. So, and this will probably be the replay. I'll probably bag the other one from this morning. So anyways, blah, blah, blah. Lag ICL, static, dynamic ID 1. Okay. I probably should have had a cup of coffee before I started this. You can't say static dynamic. I mean, you can, it'll just bark at you, right? 2, 1 by 1, 8. Okay, ports are in there. Now we'll just do the same thing. ICL 2, dist 1, ETH 1 by 1 by 1.7. No, 187. This isn't a rap song. Calm down. Cool, that's done. All right, so now let's see if my point was accurate. Nope, they're disabled. So we're gonna have to physically enable those ports because it's if you can see this, which you can, it's on the screen, but they're showing disabled. Okay. So config T, interface E. I can't see over this mic. 2, 1 by 1. Oh, that's right. So 8090. Enable. That should enable both ports. Yep, it did. Okay, so depending on your familiarity with ICX software, prior to 8090, I think prior to 8070, you would have to create a primary port, deploy the lag. You no longer have to do that. Now it automatically assigns that, but it creates a lag interface that you can do some of this management on. And the only thing I'm doing is I'm just going in and touching the lag interface because it touches both physical interfaces. So if I say enable it, it's going to enable both or however many ports are included in that lag. Okay. Interface lag 1, enable. Let's see what it did. Yep, changes 8061, you're right. And 8061 was really short-lived. It went 60, 61, and then a bunch of patches, and then it just went straight to 70, so. There we go, up and forwarding on one side. I always like to check both just to make sure this side doesn't think anything's blocking, and it's not. So there we go, our ICL's up. So now we're just gonna do the client lags. So the client lags are gonna be kind of interesting because we're going to lag. This is where MCT gets really kind of fun to play with. We're going to be lagging one interface into a lag on one device, and then both interfaces into a lag on the other. But as you can see, this in access 1, we're creating a lag on this guy, but it's pointing to 2 different devices. And on this guy, he has 1 link to it, so we'll just have 1 link in there. And that's fine. MCT is going to handle that. It'll understand that within the cluster config, and we'll be perfectly fine. Okay. All right, so let's do that. So just to check our config real quick, we have that lag built. And what I'm going to do, because the way I know this just from doing this so much, I'm going to use the main VLAN number as my identifier for my lags. You'll see this pretty common. So we're going to use for MCT client 1, the main VLAN there is 10, so the lag ID is going to be 10, which in turn means that our lag interface will be interface lag 10. So you'll see that, just how I do that throughout this process. And I mean, that's just how I do it to keep myself sane. And again, if somebody else has to log into it, look at it, it makes sense, right? So these lags can be dynamic, which is nice. So we're going to do lag access 1, dynamic ID 10. And I know these ports, so I just know them. Okay, that lag's deployed. So now let's do lag access 2, dynamic ID 20. 1122. Lag access 3, dynamic ID 30. You can see how I like sequences. My brain is so simple. Okay, all right. So that one's done. We've got side 2. Well, that was side 2 or distro 2. That one's done. So now we'll just jump into distro 1 and do the same thing. So we're going to do config T, lag access 1, dynamic ID 10. And I use the same ports on both sides, so it makes it easy. Lag access 2, dynamic ID 20. 1122, and then lag access 3, dynamic ID 30. Look at that. Done. Piece of cake. We should have a party now. We're done, right? We can go home. Made lags. They're all working, and none of them are up. Well, I guess 1 out of 4 are up. These aren't going to show up yet. So the ports A are disabled, so I need to... Well, one of them is disabled, but I'm going to enable them all just to be sure. 23. Oh. See, I just told you that's how it does it, and then I did the same thing anyways because I'm... Yeah, you know. Interface lag 30, enable. Okay, there we go. Got it. Now these lags won't come up because, and I'll show you why. So you're gonna have a MAC in here, right? And that's the system MAC of the remote side that it needs to be connected to. Well, these guys, the access switches, A, don't have a lag configured yet, and B, the system MAC won't match. So once we, basically the simplest way to put it is if you take 2 devices like with our ICL, I'll show you. Show lag 1. I'll just do show lag static. Okay. This guy here has one MAC in here, right? One system MAC that it sees, and system priority and the ID. So it sees one common MAC on the remote side of it. Now, when we create the lag in access 1, it's going to have a lag pointing to 2 different devices with 2 separate system IDs. So the system MAC will be different between them, and the lag won't establish because we haven't yet built a cluster. So once we build a cluster, then MCT will take over and create that common system MAC so that the client side, once they become alive or brought into the cluster configuration, then they see that common MAC and boom, they pop right up and it works. So MCT is kind of tweaking that MAC address and saying, hey, I'm going to give you remote clients one system MAC to look at so that the lag itself can function. Okay. So this part's really easy. We're going to do Oh, we're gonna do config T, lag, MCT, dynamic ID. The ID on the remote side is cosmetic, so it doesn't have to match. So I don't have to create 10 here and 10 there. I can create 5 here, 1 here, whatever. But just for the sanity sake of it, I'll create 10 here. And then I'll do ports E1113 to 1x1x1 because that's both ports that go up to it. Okay, so it says deployed, but again, I talked to you about that piece. Oh. I about did it again. Hey, if nothing else, I'm good for some goofy errors, I guess, right? So once it comes up, see how the partner system IDs don't match? Both of these ports exist in that inside of that lag, but the MAC addresses don't match. So it's not going to establish the lag. It will come up blocked. One side will forward. The other side that's forwarding, it's just not functioning as a lag. So we're not there yet, right? Okay. So here we go. Now we're going to do the same thing in switch 2 or access 2. So config T, oops, lag dynamic, oops, MCT dynamic, ID, and this guy's 20. Okay. Same ports, just because it's easy. Boom. Got it. Okay. Alrighty. Making progress. Now let's do the same thing over here. Lag MCT dynamic ID 30. Ports E 1x1 to 1x1 Okay, we're done. We made it. We can celebrate. Okay, now we need to create VLANs. So I'm going to create all of our VLANs at once. So I'm going to create the session VLAN. I'm going to create the keep alive VLAN. I'm going to create the MCT or client VLANs. And then after that, I'll go ahead and move into creating the cluster. Now, one thing I want to talk about is strict and loose, because you're going to see that when I do the show cluster, and it'll show you that term, and it will come up as loose. Basically, if you configure this and you're not using a keep alive VLAN and you lose your ICL, you're going to isolate your clients. Okay. Loose is basically going to keep that sanity between the two MCT cluster devices. If you lose your ICL, it will keep those sessions alive through the keep alive VLAN. It's a separate link. So we have our ICL is on 17 and 18. I'm 99% certain that our keep alive is on interface 1.1.15. So it's a separate interface. And one thing too with this, I mean, if you've got two 7750s, two 7850s or 650s, whatever you're using, let's say, for example, you build your actual lag between the two for your ICL, and you do it on the fiber ports, the stacking ports that are there, right? Like on a 7750, and you want to just run those as non-stacked ports, pure 10 gig traffic, create your lag that way. Perfect. Now you create your keep alive VLAN. You could create that on a separate port on that device. Say it could be on the same module, but the optic's not going to overheat, or it's there, or a separate port. It gives you that flexibility, so you have that ability to do that. And trust me, you've probably not been in the room with me whining about keep alive VLANs because of the structure, the physical hardware structure of the switch, and Brian informing me that I'm wrong, and I just finally had to agree that he's right. And it pained me to say it, Brian, and you know that. Made myself laugh. Okay, I'm done. So let's get some VLANs built. All right, so here we go. We're going to do, let's see, I'll show you this real quick so that you can understand. So I've got a couple VLANs that are already built in these devices, mainly in the distros and the access switches. I've got VLAN 2 is built. That's my VLAN routing. So how I would do this is I would have VLAN 2 be the primary routed VLAN within the data center, just so that I have that connectivity there. OSPF neighborship to everything. If I needed to lay anything else on it, I can. And then I also have VLAN 4, which is for intra-DC routing. So it's just different functions based on different things I was doing inside of it. But this is going to go through a pretty big overhaul, so I can probably go ahead and peel a lot of this stuff out if I need to. But right now it's there and everything looks good, so I'm pretty happy with it. But we're going to create, let me see here, 1, 2, 3, 4, 5, 6 VLANs. Okay, I'm going to create the client VLANs 10, 20, 30, 51, and 51 exists in Access 2 because that's my multicast VLAN. I'll create the session VLAN as 1000, and I'll create the keep alive VLAN as 2000. The keep alive VLAN and session VLAN numbers are not required to be 1000 or 2000. I used what was in the config guide, I think at the time, because I was extremely lazy in using copy and paste, which I'll get to that later because I'm going to do the same thing. But that's why I use those. You can use any VLAN number you want for them. There's no limit. There's no restriction on what VLAN number you can use. Okay. And I do this usually structured so when you look at point-to-point links, okay? And the rest of this environment, which I'll show you just for visual clarification, I guess. The rest of this environment, there are routed links, and they're point-to-point links, and they come out of my ag switches in the data center, and they go out to each site, okay? The purpose for those is obviously to route that traffic, but there's no layer 2 ran across them, so they're route-only links, they're point-to-point links, and they are OSPF links, or some might be BGP or whatever I'm doing with them. Those are there, and they're not touched. Now, what I end up doing is I want to make sure that I pull those links out of VLAN 1, because I don't want any nonsense going on in VLAN 1 on the device, especially if it's a routed link. So best practice, and one thing that if you ever talk to support, they will tell you a really good practice for you to do is take those links and untag them in a separate VLAN that's not used for anything else. And when I mean anything else, I mean not even other point-to-point routed links. You do them individual. So if I had port 1120 was connected to a remote site, I would create VLAN 1120 and I would untag that interface in there. And I would just name the VLAN point-to-point bucket for like a VLAN or a layer 2 bucket, basically like a bit bucket would work. But just a good practice to do that. That way you don't have any kind of issues at layer 2 with your point-to-point links, because it has happened, and that's why it was created as a best practice later on. And I've had lengthy conversations with support about that, and I'm in complete support of why they're recommending that. So, plus they're way smarter than I am, so I tend to believe them as much as I can. Okay. All right. So here we go. Let's get VLAN 10 built. I'm going to name these certain ways just because of the function that it provides when this lab is fully built. So this VLAN goes to, let's see, VLAN 10 name. I called it pfSense because that was the only client that was connected to that MCT client switch. So we'll just keep it the same for right now. I could call it VLAN 10 name. Actually, let's change it. I feel like being adventurous. MCT client 1. Okay, and then we're going to tag 2 things in here. So remember, we just created the lag that goes to our MCT clients. So that was lag 10. And then we also created the ICL, which is lag 1. So we're going to tag both of those interfaces in this VLAN. Okay, 1, lag 10. Now, we also need router interfaces for these because these will act as our gateway for the clients that are in there. And we will run VRPE with short path forwarding enabled as well. Okay. And if you have questions about short path forwarding, I'm more than happy to answer them. But basically, it will ensure that regardless of where your normal optimal path should be, it will take that optimal path. So it's not going to split brain you and say that you have to switch traffic up here to route it over here to go out. It will use that common path that it needs to get out. Okay. So we'll do router interface VE10. Again, VLAN 10, router interface 10. I like it. Okay. All right. VLAN 20 name MCT client 2. Okay. And we're going to tag the exact same interfaces in there. Oh, no, we're not. We're going to tag 1 and 20 because this is going down to the second client. Okay. Oops. Router interface VE20. Okay. VLAN 30. Now we're, oops, I got to name it. Named MCT client 3. Okay. We're going to tag lag 1 and lag 30. And then we'll do router interface VE30. Okay, I'm happy with that. Now we need to create our multicast VLAN. And typically, since multicast is going to be contained within its own VLAN and routing infrastructure and what I'm doing here, I wouldn't put anything else in this VLAN other than what my multicast sources were. I'm going to create VLAN 51 named multicast client 2. That way I know where it's at, right? And then same thing, this is going down to the second access switch that we have, or the second MCT client switch. So we're going to tag lag 1 and lag 20, okay? And then router interface VE51. Okay, 2 to go. We're almost there. So now we're going to do this. We're going to do VLAN 1000. Session VLAN. I'm going to tag, we only need to tag 1 lag here, so it doesn't have to go down to the clients. It only needs to go across between the ICLs, and this is where we're going to build our peer. So the 2 MCT devices are going to be built as a peer, and since there's only 2 devices in the cluster, we're going to use a /30 versus the /24 I used this morning. So we'll do tag, oops, I already did that. Lag 1, and then we'll do a router interface V1000. Perfect, okay. Now we're going to do our keep alive VLAN. So VLAN 2000 name. I probably don't need to put VLAN in there, do I? But I'm going to anyways. And then that one, I'm going to tag. I have a separate interface. Like I said, it's completely separate. So it's going to be tag E 1x1x15. Okay. All right, perfect. Take a look and make sure it looks good. Let's see. 2, 4, 10, 20, 30, 51. Oh no! Oh no! $2,000. Okay, and Brian caught it. Well, that's why you go back and look at it to make sure. So thanks, good catch, Brian. I appreciate it. But it's there now. So we have all of our lags built in distro 1. All of our VLANs are built. Yeah, exactly. Because I would have to go figure it out and find it. And yeah, thank you. I appreciate that. So, all right, lags are built. Something in here I don't like. That would bug me. I'm OCD enough to where that would bug me, and I know I'm not actually OCD, but it would drive me bananas. So I'm glad I pulled that out. Okay, no port names, especially when it's wrong. Okay, once again, lags are there. It looks good. Our VLANs are there. It looks good. Hey, I'm pretty happy. I don't know about you guys, but you know, I guess apparently weird things make me happy. So here we are. All right, now we got to do the same thing on the other side. So let's take a quick look at our config. I don't like that. Okay. There shouldn't be any VLANs built in here because I erased everything. Yep, we're good. All right, so let's do the same thing. Let's get our VLANs built and move on. So config T VLAN 10 named MCT client 1. Tag lag 1, lag 10, router interface VE10. Okay. VLAN 20 named MCT client 2. Tag lag 1, lag 20. Router interface VE20. VLAN 30 named MCT client 3. There we go. Tag lag 1, lag 30. Got it. All right, now VLAN 51 named multicast client 2. Tag lag 1, lag 20. router interface VE51. Boom. Okay. And now we need VLAN 1000, name session, tag lag 1, router interface V. All right. Taking bets. How many people think I can type 2000 and not 200? Don't bet. I already typed it. 1115. Boom. Got it. Okay. Sweet. All of our VLANs are there. Lags are there on both sides. And the beauty is absolutely nothing's up yet. So, okay. So now the next piece we're going to do is I'm going to take a drink of water because I'm talking too much. Which, if my wife is watching this, she will agree with that statement. Now, we've created VE interfaces. So we need to actually configure those, because if we do a show run interface VE10, it's going to be blank. There's nothing in it. So I'm going to configure those, but what I'm going to do before I do that is I'm just going to copy and paste it in there, and I'll leave it here and we'll go through it so you can see it. I'll do the first one by hand so you can see. So a couple things we're going to do is I want to create LSAs for it since I'm running OSPF. So I'm going to put that interface, all of these interfaces, with the exception of the session VLAN, in OSPF. Session VLAN doesn't need to be in OSPF. It's just peered, point to point, doesn't matter. Okay. But everything else I do want in OSPF because there's clients that live in those VLANs and they need to be able to route out and get to the rest of the world. So we're going to do that the simple way. Just put them in OSPF, be done with it. And then we'll configure VRP, and we'll do the IP address of it. We'll do short path forwarding, and then we'll enable it. One thing to note, and this is just how I do this. You could do this if you wanted to put everything on CIDR boundaries, you can. I start with distro 1 is going to be .2. Distro 2 is going to be .3, and then the actual gateway, the virtual gateway, is always .1. Could I make it simpler and do .1, .2, and .254? Yeah, I probably could, but this is just how I do it because. So interface VE10. Okay, I'll do this one by hand. The rest I'm going to copy and paste, or we'll be here until midnight. IP address 10. Now this is the other thing I use. Another thing, just to kind of help you structure this stuff out, if you're dealing with it, building it, or you need to look at this and say, I logged into a site the other day, I couldn't find anything or figure it out. You can start to implement things like this, which are helpful. I have the first octet, obviously 10. That's just the network, right? The next octet is 254, and the reason I do that is because I've specified that my data center is 254. So even though it's area 0, there could be things of 254 in there, right? Go to one of the corporate sites that you saw on the diagram. I would use 240 for one of them, 241 for another one, 245 for something. So that's all that means. It's just the area or the site. That's how I dictate that. Plus, when you get into it and you start looking at routing, then you understand that you know what you're looking at, right? So if I'm in a remote site and I'm looking at routing and I see something come back and it says 10.254. whatever, I know where it's at. I don't have to think and guess and everything else. And you can do it. I would love to do this with IPv6 later on as well, because you can actually mimic that and mirror it right on top. So you can use the same kind of address structure, which I've encouraged everybody to do because it makes your life so much simpler. Okay. And then the next octet is the VLAN. So I use 10 and then .2. And we just use a /24 here. You can go bigger if you need to, but you don't need to. Plus that gets you outside of that 10.254.10. You'd be into other networks, right? Okay, so we've got that piece. IP OSPF area 0, which is already configured, so it won't bark at me. And then router VRP extended is also already configured. So if you try to type this next command in and you haven't turned that on yet, which you can be seen, I'll have to show you in a minute. Well, anyways, it's router VRPE, just like you would do router OSPF. You have to turn that on first in global config. And then we're just going to create a virtual router ID, and this is the grouping for it. We'll do backup. We will do IP address of 10.254.10.1. Don't need a subnet because obviously it's in the same group. And then we'll do short path forwarding, and then we'll enable it, which it won't do anything because the other side is all the hello packets that are going out. It's not going to get any response. So it's just going to go active and say, sure, I'll route for it. So this will work, but VRPE isn't working yet because we haven't done the other side. So that's what's required for that. Okay. So we'll do interface VE20 now. And this is where the fun part kicks in because I can just copy and paste. It's the same thing. 10.254 data center, .20, VLAN 20, octet, area 0, VRIDs created, same IP addressing, short path forwarding enabled. There you go. Okay. VE30 now. And now we'll do interface VE51. I'll go ahead and, oops, it's going to do it twice, but that's fine. Okay, now, somebody is sitting there wondering, what's he going to do for VLAN 1000? Because you can't create 10.254.1000. Well, I'm going to cheat, and I'm going to do IP address 10.254.100. And this one, I'm just going to use .1 for this because there's absolutely no reason I can't, and it's a point-to-point anyways, so there's no VRP or anything. We'll just use 1 here, 2 on the other side, make it easy. Boom, we're done. Okay. You know what I just did? I just copied and pasted from the wrong config. And I just made all of this guy using .3, which is supposed to go in distro 2, but that's fine. You get the gist of it. It's a copy and paste failure. So I'll manually configure V10 over here in distro 2. Oh wait, what address did I put on it? I might have done the same thing. No, because I typed it. Okay. VE10. So that one's fine. And then I'm just going to dump the rest of this in here. And so for this one, I'm going to have to put 1's addressing in it, but that's fine. You get the gist of it. I mean, I know it's frustrating. If this was production, I would absolutely change it right now. Brian might actually tell me to change it. And if you do want me to, I will, just to make it sane. Because I can. I don't think it's a big deal. Actually, I'm going to, because it's going to drive me nuts anyways. 51. Just do this all real quick and then fix it. Uh, 100.2/30. Okay. Let me see if I can fix this real quick. So, show you how quick and easy this is to fix. Oh, you're just going to be that way about it? Fine. Yeah, I'll have to tweak that. I think you're right. So that was 20. Yeah. Heck with it. I'm not going to waste everybody's time with it. Addressing is, I mean, for the most part, for what we're doing, is kind of cosmetic, but it'll work, right? We don't have anything duplicated. It's not going to freak out that way. So I think we're okay. It's just not addressed the way I would want it. I would go in and fix it, but I think overall we're fine. So everything's up, everything's working. There wasn't any, I think the backup commands, there wasn't anything specified. So show IP verp brief. Excuse me. Yeah, I mean, if I have any goofy behavior there, I would go in and adjust root bridges where I need them to be, and then adjust the verp masters where I needed them to be. But as you can see, everything's up and working right now. We have master, backup, backup, master, master. If we look at the other side, we should see the opposite of that. And we do backup, master, master, backup, backup. So that's exactly what we wanted to see. So that part of it's good. I think we're money for the most part right there, and I'm happy about that. So Now we get to do the fun part. We get to build the cluster, and the cluster is where everything will tie together. The client lags will come up, everything will start to behave, we'll see all the traffic running through there. The MAC DBs will be shared between the two, forwarding paths will be shared between the two, and we'll see it all start to shine. So let's do it. So we're gonna do config T, and we're just gonna call this cluster DC1 because it's our data center, it's our first cluster that we're building, right? Now this one, 51 was set to 100 on both. Reggie. Oh, in that show brief, hang on a second. 100 for 51. Let's see over here. Ooh, 100 for 51. Yep, you're right. 100, 100, 200, 100, 100, 200, 100. Ooh, yeah, why did it do that? There. We'll show it. Everyone's a backseat driver, let me tell you. I'm kidding. I encourage you to point that stuff out. I want to make it right. Okay, so for these guys in the cluster, we have to create R bridges, and we're going to create an R bridge for every device that is participating in MCT. So what I mean by that is within your MCT cluster devices, and here our MCT cluster devices are distro 1 and distro 2. Okay, the clients don't speak MCT, so they don't care, they don't do any of that, right? But the clients or the clusters need to know this information, okay? Because if you look in the MCT clients, there's 0 MCT config in them. They just form a lag, they're done, okay? But here we need to create our bridges so that we can designate who is who, okay? So for this one, since he's the first device in the cluster, I'm going to give him an R bridge ID of, R bridge ID of 1. Hey, as long as you're in a seat, I'm good with it. I don't even care. Just sit down and stay here. Don't go anywhere. Okay, so we'll give him R bridge 1. Then we're going to create the session VLAN, which is 1000. We'll give it the keep alive VLAN. IP address is configured on VE1000 will not be advertised as connected route by any routing protocol. So I want to clarify this because I said something earlier. I said they're directly connected routes. They'll be able to speak to each other. A directly connected route is a route. Okay. It's 2 devices, link between them, same subnet. They become directly connected. They can speak to each other. All this is saying is it will not be advertised in any routing protocol whatsoever, no matter what. No matter what you do to it, it's not going to inject that route. Okay. So OSPF is not going to pick it up. It won't go in there. Okay. That's all that's saying. Okay. So the keep alive VLAN was 2000. And then our ICL was ICL, what was it? Lag 1. And then our peer was 10.254.100.2. And we're going to tell it now, you need to know this before you can configure this part, but it's pretty simple. We used RBridge ID 1 here. We're going to use RBridge ID 2 over there because it's simple, right? So there's RBridge ID 2, and then we'll just say via the ICL, okay? All right, now going back 80, 60, and prior was when you had to deploy lags. Doesn't matter what version of software you're in now, you have to deploy your MCT cluster, and that's a good thing. So it's a safety net. I don't want to deploy this yet because I don't have the other side configured. So it gives me the opportunity to put the configuration in the switch, and then I can deploy it after that. And once I deploy it, then everything should come up and I can add all of my clients in as well, right? But I'm not going to add my clients until I deploy the cluster and make sure that everything's sane. So I'm going to jump over to the second device now, the second distro, and I'm going to build that cluster first. Then we'll deploy them real quick together. It'll come up and it should be happy there. And we'll just make sure that it comes up and we'll be good, okay? So cluster DC1, okay? Same thing, so RBridge ID 2, okay? Session VLAN is still 1000. Keep alive VLAN is still 2000. It's still telling us it won't advertise that connected route in and any routing protocol, ISIS, OSPF, doesn't matter. Okay. And then ICL is ICL lag 1. Our peer is 10.254.100.1. Right, I didn't cross those up, did I? No. Our bridge is going to be 1 on the remote side. So we've specified my R bridge ID is 2. My peer's R bridge ID is 1, so we know where we're going. And then via the ICL. Okay. All right, now let's see how fast I can be. Ooh, I want to race. Let's see. Everybody ready? Did it take the first one? Ooh, it did. Lightning. Lightning McQueen. I'm going to give it a moment to form before I get all impatient and start blasting show commands at it. No, I'm not. Okay. Here we go. Cluster DC1. R bridge ID 1. That's who I am. Session VLAN, keep alive VLAN. That's all good. Cluster state is in deploy. And it's also loose. So we have a keep alive VLAN. We can lose our ICL. We'll still have traffic flowing. We won't isolate the clients. Okay. Our member VLAN ranges are VLAN 2, 10, 20, 30, and 51. And the reason that 2 is a member VLAN range is because it is tagged on the ICL. Okay. ICL info just gives you the name of it, what port it is, and the trunk. So that's the ID number, right? Peer info. So our peer is .2. Its R bridge ID is 2 via ICL, and then the keep alive interval, hold time. Obviously, this stuff has to match. Active VLAN ranges, and then last reason for client cluster or cluster communication protocol down is not down, and the peer state says CCP is up. So it's been up for 17 seconds. It's all good. If any of this stuff on the other side was off kilter, out of whack, whatever, it wouldn't be up. So we know that part of it's good. Okay. So now let's do this. We're going to bring one MCT client up at a time. Okay, so I want to show you two things. So we're going to bring up client 1 first. So we'll go to cluster DC1, and then I'm going to do client. I'm going to call this access 1 so I know which switch it's going to. And then we're going to give it an R bridge ID of 10 because that's the identifier we used for everything else, right? Okay. Config T, cluster DC1, client access 1, R bridge ID 10. So again, the two MCT clusters are going to look at what the R bridge ID is of that MCT client, and it'll know exactly who it is, right? R bridge ID 10, client interface is lag 10. Did I do that on the other side, or did I miss that? I did. So I did the client that, so we need this. So you tell it its R bridge ID, you tell it which lag interface it's using going southbound, and then you have to deploy it. So we'll deploy him. Ooh, I wasn't trying to be all super fast here. And we'll deploy it here, okay. Okay, so let's do a show cluster over here again and see what changed. Oh, we have client info now. Number of clients connected. 1, right? It's in deploy, and it says that its local state is local up. That means me locally, I'm up. Let's see what this says. Okay, now FSM state here says up. This guy should have updated. Up. Okay, it's up. So now if we look here, see how I did the show lag here and it showed two separate partner system max? That's the remote side. Let's see what it shows now. Hey, they match. So MCT created one, provided it, boom, good to go. And it can create these goofy max because it's local, right? It can kind of do whatever it wants. So it works. We've got it up. We've got it working. The lag is up. The MCT client is up. So let's build the rest of them because there's no reason not to, right? So exit out of that. Now we're going to do client access, 2. Our bridge ID is 20, right? Client interface lag 20. And I'll go ahead and, yeah, I'll do the other side first. I'll get ahead of myself. Client access 2. Okay. Our bridge 20. Client. I can't. I always forget that dash. Lag 20. Oh, wait. What? Okay, it's saying that error port 1122 is a member of VLAN 1, which is not a cluster VLAN. So it hasn't been tagged in the correct. Interesting, it's not tagged anywhere. Which means that in VLAN 20, I never tagged it. Wait, what? Did I put the wrong interface in lag 20? 1122 is in. It's lag 20. It's tagged in lag 20. It's also in VLAN 1. What? Okay. VLAN 1, no untagged lag 20. Yeah, but the weird thing is it wasn't there earlier, and I guess that just kind of, I don't know how it got tagged in there or untagged in that VLAN again. It's up. I don't know. Okay, sorry. There, it took it now. So, okay, a good gotcha. And I like making these mistakes, especially on here, because if I do that, you see that there's these gotchas, and that's usually what it is. So there's evidence that has been long-standing for the course of my life that I'm not perfect, and I don't pretend to be. But also that I'm very happy when people can learn from my mistakes or my oversights. So there you go. You have one right there. Okay. So now I need to deploy this on both sides. Okay, I'm going to create the third client access 3. We're going to give it our bridge ID 30. We're going to give it client interface lag 30. Oh yeah, Brian, you're probably absolutely right. I just didn't verify. Well, I know you're absolutely right because that's what it did. I just didn't verify it. So, and you know, this is probably real world stuff. Somebody else might run into this. So, like I said, I'm more than happy to make mistakes as long as I can correct them on the fly and make it work. Our bridge ID 30. Client interface lag 30. Don't bark at me. We'll deploy it. We will deploy it. And we should be in the money. I'm so confident right now. I'm just going to do a write mem and say I don't have to reboot it to make it work later. Yeah. And I know that. So one thing I will say too is support's recommendation, and Ben Beck was on here earlier, and it didn't come up, but I believe the recommendation that's come out of support has been 8092 recently. And even like Brian's saying, who knows if it's resolved there. 8095 is out. It could still happen in there. I'm not really sure. And I'd have to dig through Jira to find the defect anyways. But, you know, it is what it is right now. So, all right, let's check it out. We have all of our lags are not up. Up and forward. This one's not up. 123. Did I create that one? Hey, wake up. These ports never got enabled. That's why we're checking it. So we'll give those a second to come up. We'll do a show lag again, make sure they're all up. Then we'll check our cluster, and then we should be good to go. All right. ICL is up, obviously. Access 1 is up, access 2 is up, and access 3 is now up and forwarding. Awesome, all our lags are up. So that means in terms of what this guy sees, the ICL is up, and also all the clients are up. So that's great to see. So let's verify this guy now. All right, ICL is up, as you can see here. Access 1 is up, access 2 is up, and access 3 is up. High fives. We did it. It works. MCT's working. We're good to go. So there you have it. That's how you do it. Fun times, right? Hey, real quick, I just want to tell everybody that this is probably... Oh no, my Stream Deck just exploded. Let me see if that'll work again. This is not probably. This is absolutely one of the absolute highlights of my job that I get to do this. I feel very fortunate. So the simple fact that you guys can grab the stuff, learn from it, look at it, absolutely love it. Your suggestions, feedback, everything are always way more than welcome. And if you want to provide those, please do. So real quick, let's see what Brian said. Not a defect, just a change in 8090 that when you add the individual interface to a tag VLAN, it is not removed from the default. I think the interface was added to a VLAN before the lagged form. So like, oh, yep, the lag inherited VLAN 1. That's exactly what happened. Which is good to know. I mean, that information is now here, commonly known to everybody, and also you've seen it, right? So you know what to look for. So again, please, everybody, come back, tune in. You know, we're going to keep building on this thing. I'm going to keep continuing to do this. Yeah, I absolutely love this. So stay safe, stay healthy. Try to have some fun, enjoy the world a little bit, and we'll see you next Wednesday. Thanks a lot. Oh, wait, did you go through? Oh, Brian makes an excellent point. You know what? I'm not done. Watch this. Hold on. Hi, Allison. How are you? If you haven't subscribed, you should, because we put a lot of great content out here, but guess what? We're not leaving yet, because Brian just reminded me that I didn't do the one thing that would make me mental if I didn't do it, so we're going to do it now. Okay. Oops, I forgot the brief. Well, I get, you know what? There's this one thing I haven't thought of. I've never slapped... I don't think I've ever manipulated root bridges. Hey, Kai89 just subscribed. Thanks, man. It's good to have you. Ma'am, man. I mean both. I've never actually done that in terms of throwing a spanning tree in there to tweak that. I mean, you want me to use rapid to do it and just set the priorities so that they line up and match? I can. I don't really care. I just never actually configured rapid in here on top of it. I'm going to. Okay, we'll use rapid and I'll throw it in there. So this is how I'm going to do it, okay? I want to, and Allison, hopefully you're still here because this is the best part of this. So if I look at how my traffic traverses now, right? Show IPv brief. All right. VE20, distro 1 is the master. For VEs 10 and 20, VE 10 and 20, distro 1 is the backup, and then the other two, 30 and 51, I'm the master. So what I don't want to have happen is I don't want to be in a situation to where, I'll use an actual example of this and blow this thing up a little bit. Let me look. 10. Okay, so 10. This guy's the backup, the VRPE. What I don't want to have happen, because this topology still exists, right? I don't want my traffic to be switched up to distro 2 at layer 2. It switches up there, and then have to switch across to distro 1 to route out, because that's the actual layer 3 gateway for it. So I want to marry those two up, and I want to make sure that rapid spanning tree is built and I force who the root bridge is, okay? Because right now I don't know, and that's a big no-no that needs to be corrected. So we're gonna do this last. I probably should have done it first. A little bit out of order. It'll still work. Everything, traffic will still flow. It's just not ideal. It's not working the way it needs to. It's not optimal. Okay. So this is the optimization part of it. And if I do this now, so we're going to do it for all of these VEs, all these VLANs, because all these VLANs go down to our client switches, right? So first thing I'm going to do is I'm going to specify how my root bridges are going to work. Okay. So I'm going to pull it off the default. I'm not going to allow the 32,000 whatever default root bridge priority to work, and then just let the election go through based off of the lowest MAC. I'm going to force it. So if I want that device to be the root bridge, its spanning tree or rapid spanning tree priority is going to be 1024. If it's the backup, it's going to be 2048, and there should only be one root and one backup in this sense. Distro 1 and Distro 2. One of those is going to be the master or the root. The other one's going to be not the root. And then the client switches, they'll have a priority of 4096 because I want those to never get brought into the equation, right? If I have a switch die, I want it to just flip to the other distro. That should be my layer 2 domain, okay? So I'm going to do config T VLAN 2 and then span 8. So the full command for this is spanning tree. And then if you hit question mark, you see, I talked about rapid spanning tree, and you see this statement here, RSTP. Don't use that ever, please. It's a draft version of rapid spanning tree. The correct version to use is the IEEE 8021W. That's a full-blown version of it that's not a draft. So we're going to do span 8, okay? And then when I do span 8, I'm just going to do a priority of, I said for 2 or master, right? But this, yeah, 1024. Okay, so now I'm going to go to VLAN 2. I'm going to do span 8, and span 8 priority is going to be 2048 because, as you can see here, he's a backup. So I'm just going to lay that on top of that, make it match. Okay. VLAN 20. Span 8. Oops. I knew I was going to do that. Same thing. He's a backup. I want to do the same thing. Okay. VLAN 30, span 8, and then span priority of 1024. Oh, I did 30 first, didn't I? All right. What? 22030. I'm confused. Oh, it disabled my lag. Oh, no, it didn't. Hold on. It disabled spanning tree on the lag. Okay, we're good. But it's already configured there. 51 was the last one, so VLAN 51, span 8. 8 priority. The only thing I don't like is it won't let me VLAN 30. Oh, there it will. Now let me put it in there. Okay. So I'll show you an example of this, okay? Let's take VLAN 51 for example, okay? We basically said that you're going to be a priority of 1024, okay? So if I do a show 8 VLAN 51, this is your bridge identifier. This is who you is. Who you is. I just said who you is. Who you are. The bridge, the switch that you're looking at, your bridge identifier, that's its bridge, right? So the first 4 characters in here is the hex equivalent of the decimal priority that we put in there, okay? The rest of it is your MAC address. So if you look, you would see this is the system MAC address. It'll also tell you who your root bridge identifier is, and they match. So we know that this guy is the root bridge for this VLAN, which is exactly what we wanted, and we're good to go, okay? Now if I do the show IP VRPE brief again, it's going to show me that 51 is master here, and it's also a root bridge, so all our layer 2 traffic goes towards this switch, and all of our layer 3 traffic goes towards this switch, so everything's laid on top of each other. And I don't remember I said this or not yet, but Brian just said this is the best practice for non-MCT deployments, and that's absolutely correct. You should do this in every layer 2, layer 3 environment where you're switching and using VRPE. Okay. All right, now let's do the same thing over here. I need that brief on there and I keep missing it. So here we go. VLAN 2, span 8, and then span 8 priority. It's a backup, so 2048. Oh, you mean you want a priority in there? Jeez, you're picky. VLAN 10, span 8 priority 1024 because he's master VLAN 20. Another master. Hug. Okay. VLAN 30. Span 8 and then span 8 priority of 2048. Okay. VLAN 51. Span 8. Okay. Distros are good. I'm happy with those. Show a VLAN 51. Now this should have root ports going towards the other switch, which it does, which is the ICL. So that's its root port to it. And it'll show that this is your identifier. This is who I am. Root bridge identifier. That's who it is, which they don't match, right? Bridge is one thing. Identifier goes to the other one. I don't believe you. No, 2048 here. This is a backup. Wait a second. Was I right today? Did I win this one? Hold on. I gotta mark this. Where's my calendar? You're not out of order, are they? No. Yeah, 51 should be 2048 because it's a backup here. Never mind. Ignore that. Can I edit text and delete it? I'm kidding. Okay, so now we're gonna do this. The one thing I'm mainly worried about is VLAN 2. So show 8 VLAN 2. Yeah, I got one. Got him, finally. Okay. All of... This is distro 1, and I'm the root bridge for it. So I want to make sure that in my access switches... Oh. Oops. I better shut up and stop bragging. You didn't see that. 4096. I never created the access VLANs in the I never created the VLANs in the access switches, so it didn't matter anyways. So VLAN 2. Priority 4096. Okay. So now if I do a show 8 VLAN 2 just for fun, this should show me that. What do you think that? Oh, yeah, it's fine. Why do you think you're a root bridge? But they wouldn't care because they're designated forwarding anyways. Okay. That doesn't matter. What matters is that your two distros know who the root bridges are. Spanning tree isn't going to function down to the access switches or MCT clients. So as long as your distros know that they're the root bridges, then you're good. You're not going to have a loop anyways because with a lag, everything's forwarding towards it anyways, right? So there we go. We have it. I'm happy with it. Although I don't think I created the rest of the VLANs in these guys either, did I? I did not. So config T VLAN, what was it? 20 and 51 is in there. And then I'm going to tag lag 20. So that's what I made it. So now traffic can get up there. And in this one, I'm going to do config T VLAN 30, tag lag 30. And I'm happy. Okay, we did it. We created MCT. Clients, everything can get up and down. Everything's good. Everything's happy now. I mean, the only thing you'd have to do is go in here and find all of your clients, untag them in the appropriate VLAN, and you'd be good to go. Okay. Cool. All right. I appreciate everybody. I think we've officially built MCT fully, so we have everything in there. Root bridges are designated. VRPE is designated. Everything looks great there. I'm pretty happy with it. So, and Brian, you are not a broken clock, so you're right more than twice a day, and you know it, but that's fine. We're not going to argue. So anyways, thank you everybody for joining. I can't thank you enough. Remember, every Wednesday, 11 a.m. Mountain, 6:30 p.m. Mountain. Send suggestions if there's stuff that you want to see. We're more than happy to do it. We absolutely love being here doing this, and we can't wait to do it again. So we'll see you next Wednesday.